Good morning and welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want to introduce chapter 3 of Pure Mathematics 2, which is Exponential and Graphs. And I want to differentiate between two things. Ordinarily, we are used to graph of y is equals to x squared, whose shape is simply like that. You can see the variable is actually the base and the index is a constant. This one is a controlled function because the index is actually a constant. It doesn't change. But I would want to introduce something to do with y is equals 2 raised to power x, whereby the two of them interchange positions. And this is now this is a quadratic function, and this is an exponential function. This is a quadratic function, and this is an exponential function. Exponential function. And what we mean by an exponential function is that when x increases, the function increases without limit, because we are going to have a function and a graph that looks like this. And I want to explain two features. I want to explain two parts of this graph. The moment you have an exponential, there is a region you will see that looks like this. This region is actually asymptotic. Asymptotic along x-axis. That means what? This graph will never touch the x-axis, but as x decreases, it will continue to approach 0, but it will never be equals to 0. I will explain that. You will see another feature here, whereby this is 1, and this is y is equals to 1, and the next picture, that particular point, this is very important for that, and it will say that all exponential graphs pass through point 0, 1. Reason being, if we have, for example, this kind of a function, y is equals 2 raised to power x, when x is 0, 2 raised to power 0 is 1. And any number raised to power 0, regardless of the base, will always be 1. So all exponential graphs will pass through that particular point. And this is the third feature, whereby you can see this is feature 1, this is feature 2, this is feature 3, this is 1, this is 2, and this is feature 3, whereby as x increases, y increases without limit. It increases without limit, telling that, or meaning that when as x increases, y increases without limit. And that is to say that as x increases, y increases exponentially, and that is now the meaning of the word exponential, because exponential to some extent in this particular case can mean uncontrollable change or limitless change. So you can already see the features I've talked about. Asymptotic along the x-axis, because the graph will never touch the x-axis, meaning that regardless of the value of x, y can never be 0. All of them will pass through the point 0, 1. I've said y. And you can see there is an exponential increase as x increases. And that is just an introduction of this topic, and I would want to practically now show you what happens in such a case. But before then, I would wish to uh, stop there as far as this video is concerned and make a brief introduction of this particular topic and explain further the difference between a quadratic function or a cubic function and an exponential function. This is, you can see the difference. This one doesn't, it has no asymptote unless there is some kind of transformation which we have seen before. This one does not increase exponentially, and it does not necessarily pass a specific point. This one is asymptotic along this particular point. It must pass through the point 0, 1, and when x increases, y increases limitlessly or uncontrollably, or even better, exponentially. All right,